Okay. Okay, we're now recording. So just to flag up, I'm sure you all know anyway that all of these live sessions are going to be recorded, and they're going to go onto our YouTube channel. So they will be public. There won't be. I don't see that there will be much traffic probably beyond yourselves looking at this. But just to let you know, these live sessions will be recorded. Yeah. If you're uncomfortable being on that video, if you feel better turning your video off, that's absolutely fine. I've got the participant list minimized, so unless you actually speak up during the session, then you won't be on the video anyway. So that this shouldn't be an issue, but just to flag that up. So good morning, everyone, and a very warm welcome to our very first training session of the Health Service Modelling Associates Programme, Iteration 3. A number of us have said how quickly this has come around. It seemed like only yesterday we sent out the application forms and I had the open day. And it's great to see, obviously we met a number of you at the open day, but there's a number of you who weren't at that, that applied after that, and it's fantastic to see so many of you here. This is by far the biggest HSMA program we've ever run, and we're really excited to be working with you all. We've got a fantastic training program lined up for you over the next 3 months. We're going to start fairly light today with some general introductory stuff. So this morning we'll be doing some intro stuff around OR and the modelling process and data science, and then this afternoon we're going to dip our toes in the world of programming, not by doing anything hands-on first of all, but just to have a look at some of the programming concepts, the fundamental programming concepts, so that you're a little bit more aware when we start on Tuesday, actually getting you to build some computer programs in Python. So just a few points of order before we go any further. If you've got any questions during the lecture, then pop them in the chat. I've got one of my fellow Pencordians, Sean. Sean's going to monitor that. At various points, I'll ask if there are any questions up to that point, and Sean will let me know. If there's anything particularly urgent, then and Sean needs me to stop, then he will happily interrupt me. But any questions, pop them in the chat. And remember that outside of these live lectures, you'll all be using Slack. So I'm sure you've all read the instructions now, but you'll be working within your peer support groups. So for all of the exercises, you'll be working within your peer support groups, talking, chatting in there. And so if you need any help during any of the exercises, your first port of call is your peers in your peer support group, and see if you can solve the problem. If none of you can and you need help, then somebody from that group should just post in the HSMA Support Hub channel that you need a mentor. If you can put the name of your group, your peer support group, so we know which one you belong to, and we'll pop in and see if we can help. We'll also be floating around. We've got access to all the peer support groups, so we'll be floating around, and if we think we need to step in, then we will do so. Fantastic. So before we sort of start in earnest, I just want to introduce myself and introduce my colleagues. So I'm sure you all know by now, my name's Dan Chalk, Senior Research Fellow with PennARC, which is the National Institute for Health Research applied research collaboration for the Southwest Peninsula. And within that, I belong to a team called PenCord, which is basically the operational research and data science team within PennARC. And I lead the HSMA program. You'll be sick of my voice over the next 3 months because I'll be delivering a lot of the training, particularly over the next month, where I'll be taking you through programming and discrete event simulation. But we've got a number of us in the team. And before I introduce the rest, I'd just like to hand over to our director, Martin Pitt. Martin, I believe you just wanted to say a few words of welcome to the program.
Yeah, hello everyone. Unlike Dan, you won't be getting sick of my voice because I'm not going to be with you for much of it, but I'll dip in now and again, and I'll obviously be keeping a keen eye on how things develop. As Dan said, I'm director of PenCord and the HSMA, the Health Service Modelling Associate Programme. started many years ago was as a kind of apple in our eye, if you like. We thought it would be such a positive thing if we could do this. And it's proven to be the case. And I think both the 4 iterations of the program have gone extremely well. And there's somebody who's giving feedback. I don't know.
I think it might be Greg Cobb. Sorry, it's just flashed. Greg, sorry, can you mute yourself? If everyone can mute themselves unless they're speaking, sorry, we get it.
It's hard enough hearing my voice when it's 1 rather than 2 anyway. But no, it's been a tremendous success, and we're really hopeful of seeing it develop and flourish into something really important in terms of bringing on health analysts. And just to say, we really welcome any feedback you have. I'm sure Dan will say this at some point too, but if you can give us any feedback about how you feel the course is going, what's working really well, what's not working well, or what could be, what we could do to make it even better. All those things are really useful in helping us develop the scheme, which I think has been a major success. Not least in terms of just linking us up with the reality of what it means to deliver health service analytics and operational research, at the front line of health service. It's something that we're always very keen to do. So it's very beneficial for us as a research group as well, and it keeps our feet on the ground to some extent in terms of making sure the tools that we have are used really fruitfully in terms of improving healthcare. So I'll say no more, but I wish everybody very well with the course, and I'll hand it back to you, Dan, in your capable hands. Thank you.
Fantastic. Thanks very much for that, Martin. As I said, I'm going to be taking you through a lot of the introductory stuff and particularly around programming in Python over the next few weeks. And I'll also be showing you how to do things in discrete event simulation, where we model pathways. I'll be showing you how to do things in system dynamics, where we model whole systems and the flows between elements of whole systems. I'll be showing you how to do natural language processing, which is a really exciting AI-based set of methods where we can extract information from free text, and also showing you agent-based simulation as well, which is where we can model individual level dynamics, particularly used in disease pandemic modeling, funnily enough. Indeed, the example that we will be taking you through in that will be to model a disease pandemic. Can you ever imagine that happening? That should be interesting. So before I carry on, I'd just like to introduce you. We've not got all of the Pencordians here today. There's a couple that are on leave. But just to say a little bit about who they are and what they'll be teaching on the program. So if I can start with Mike.
Hello there, everyone. Mike Allen here. So on the course, I'll be teaching you machine learning, which is, we'll be looking at classification. So given, large data sets, can you tell whether something is one thing or another? And also reinforcement learning, which is sort of, I think, one of the most interesting emerging bits of AI. And we'll be looking at the sort of things that Google DeepMind produces, the sort of things that can learn to beat world chess champions and Go champions, and starting to think about, can these things learn and be useful in health service settings or police settings as well. So look forward to that.
Fantastic, thank you, Mike. And Mike will also, as you've already seen, every now and then post a nice video of a fantastic free software song, which will get into your heads very quickly, I'm quite sure. Sean, do you want to go next?
Morning, everybody. Yeah, I'm research fellow with Pencord. Many of you will know me, and so I'll be teaching you on this course. We're going to be looking at R, looking at so trying to teach all of R in a from the basic stuff of writing simple programs in R to going through to looking at advanced graphics with ggplot, looking at what else are we going to be looking at? Oh yeah, distribution fitting, always an important one, and building Shiny apps as well, which is something that probably be of interest to a fair few of you. And then also going to be teaching network analysis. So this is something that we can use for looking at interactions between different elements of a system, and is particularly useful for large-scale system modeling. So look forward to those sessions.
Fantastic. Thank you, Sean. And Alison, do you want to just introduce yourself?
Hi everyone. My name's Alison. I'm the newest member of the PenCord team. I just started in April, just after lockdown began. I won't be teaching on this course, but I may be mentoring some of you. So anyway, looking forward to getting to know you all.
Fantastic. Thank you, Alison. And I presume, is Tom here, or is Tom still not there? No, Tom. If Tom was here, he'd say, hi, I'm Tom. And I'm going to be teaching you particularly around forecasting, which I know a number of you are interested in and expressing interest. So Tom's got some fantastic forecasting stuff to go through with you as well. Fantastic. Okay, let's get cracking. Let's start your HSMA journey. We should probably first explain what operational research really is, because we're going to teach you it for the next 102 hours. So let's demonstrate using a simple exercise. Okay, I want you to imagine that you are in charge of an emergency department, and you've been asked to cut costs, and you've got to do so quickly. And you've got two options. You need to get rid of a senior nurse, or you need to get rid of a treatment cubicle. And just for the purposes of this exercise, we're going to assume either the costs of those are the same, or rather more realistically, that either of those will solve your cost problem. Okay, so what you're going to be looking to do is to take the action that results in the least impact for patients in terms of the amount of time they spend in the system. So I am now going to share my whiteboard. I have to do that first. Right. So this is the system that we're going to be looking at. So we've got patients. Patients come in, and the first thing they do is they register at the reception desk, and they've got a single receptionist that deals with registration. They then get seen by a nurse to be triaged, and we've got two nurses in our system at the moment. See, my art skills are fantastic here. And then from that point, after they've been triaged, they then get treated, and they get sent to one of 4 treatment cubicles here. Let's put treatment there. And then after that, they leave our system in some way. Okay, so highly simplified representation of one aspect of ED. Now, we know that patients are coming into our system on average every 8 minutes. And on average, it takes them 2 minutes to be registered at the reception desk. It takes them 5 minutes to be triaged, and it takes them on average 30 minutes to be treated. So what I want you to do in your groups is to answer 3 questions. First of all, how long do they spend, does the average patient spend in the emergency department now? Okay, so imagine you've taken look at the average over the course of a year. How long on average do you think a patient spends in the emergency department now? Then, what decision are you going to make? Are you going to get rid of the nurse, one of the nurses, or one of the treatment cubicles? And then I want you to say, based on whatever decision you make, how much longer do you think a patient will spend in the ED on average because of that decision? We know that both, you're taking a resource away, so it's likely that both decisions are going to impact patient times in the system in some way. So how much longer, what do you think the impact is going to be? Now, I'm going to give you just 5 minutes to do that. I want you to work within your peer support groups. And if I can just go to Slack, just see. Will it let me do this? Okay, so I think it won't let me do that without getting rid of that. So if you go into Slack, hopefully you're all logged into Slack. If you go to the module 1 channel, you will see that there's a poll in there, and I want you to talk about this in your teams for the next 5 minutes, and then I want you to answer those questions by voting in the poll. Okay, so I'll just get rid of this drawing because I can bring up the slide in a minute. Just stop sharing that. So just show you. Okay, so if we go into module 1, it'll be a little bit small on your screen because I've got high resolution on here, but you'll see that if you go into this, there's a poll here, and it asks you each of these 3 questions. What cost-saving decision should we make? Get rid of the nurse or get rid of a treatment cubicle? How long do you think patients on average will spend in the ED pre-change? And then there's 2 questions here, depending on whether you decide to get rid of the nurse or decide to get rid of the treatment cubicle. So if you decide to get rid of the nurse, answer that one. How much longer do you think they'll spend in the ED if the nurse is removed, and vice versa if you do that for the treatment cubicle? So I'm going to give you until 5 to chat within your peer support groups, bounce some ideas off each other, and then start voting. So off you go. Sorry, I probably should have brought back up the the information. Has it retained the whiteboard? Yes, it has. Oh, that's good. That's handy. I should have tested that first. There we are. You can see from my scrawls the numbers that we're dealing with. I see lots of chat going on. This is brilliant.
Dan, we just got a question from David saying, how do we find our peer support groups?
Sorry, I was on mute. I didn't see that. So you should have a number of channels in Slack that start PSG. You should only have one because you've only been allocated to one. So you should have a channel that says PSG underscore, and then it'll either be baked or tart, banoffee pie, bread and butter pudding, Eton mess, or sticky toffee pudding. If I just have a look, I think, oh, actually, Sean, can you have a look? I think I put in it was either in the Tannoy or the Plaza. I think I put links to that yesterday.
Yes, yeah, so the list is in the HSMA Tannoy.
Yes, so
you'll be able to find the list there.
Yeah, and then you should be able to just click on the link to get into the right group. Very interested to see how many of the PSMAs and alumni get this correct, given we've done this before.
Yeah,
how good their memories are.
If you've done this before and remember the answers, just help. If anybody is still unsure of which group they're in, let me know in the chat, and I will post which group you're in.
Brilliant, thanks, Sean. That'd be really helpful. I'm going to give you another 2 minutes. You got 2 minutes. Should have also said if you get this wrong, you're automatically suspended from the course. There's no pressure. I, of course, joke in case anybody thought I was being serious. Okay, so 1 more minute. So if you haven't already, cast your votes now. I'm going to have a look, see if I can... Oh, votes are coming in. Okay, we've got about 75-25 split at the moment for getting rid of the nurse. Most people think the patients will be in ED less than an hour. Okay, it's another 30 seconds. I think the poor nurse is starting to get worried. I also like the fact, I'm just noticing that a lot of you think the treatment, those of you who think the treatment cubicle is the way to go, think it'll be disastrous as well. You have voted that it'll be a significant impact on the system, but maybe it's the lesser of two evils. Okay, I'm going to stop us there. Let's have a look at what you've said. So 77% of you, overwhelming majority, think you should get rid of the nurse. And 23% of you think you should get rid of the treatment cubicle. So most people are saying go for the nurse. How long you think patients spend on average in the ED, most people think it's about 30 to 60 minutes. A few people think it might be between 1 and 2 hours, and even fewer between 2 and 3 hours, and one person thinks more than 4 hours. How much longer do you think patients will spend if the nurse is removed? Most seem to think it'll be about 30 to 60 minutes more, and a few others think maybe something a bit more trivial than that. How long do you think they'll spend extra if the treatment cubicle is removed? Most seem to think that will be quite a lengthy increase. So let's find out. So if we go back here, just checking everybody. Sean, could you see the slides okay?
Yep.
Yeah, brilliant. I'm conscious that I'm dancing around all over the place. Okay, so we could have built a model in order to help us answer this question. Okay, so what we could have done is to build a model, and then we could have built a base case scenario first of all. And a base case scenario is basically a model of the current system. How are things running now? And what we can do is we can use this to see how well the system's working. We can see where there are any bottlenecks, where the queues are forming. We can also use it to validate the model as well. So we can use this for our 3 questions. We can use that for the first question in terms of how long we think patients are spending in the ED now. We can plug in that data. And we can also use it to get some sense about what cost-saving decision we're going to make. Because just by seeing what's happening right now, we can get a sense about what might be, where the queues are forming, and what might be a good idea to remove and what might not be a good idea to remove. The power of operational research, though, comes in terms of the what-if analysis. Now, what-if analysis is basically where we test various scenarios in the model in order to ascertain, to predict what we think might happen if a certain change was made. So we can use that to predict the impact of decisions. We can provide that to the decision maker, and that can be part of their evidence that helps them to make an informed evidence-based decision. So we can use that here to get some more information about what cost-saving decision we should make, because we can test both of them out. And we can also use it to get some sense about what the impact will be of our decision. So how much longer they're going to spend in the ED. So I said we could have built a model, and in true Blue Peter fashion, here's one we made earlier. So I'm just going to bring up the model that we built. 2 seconds. So I'm going to show you a model in something called Python in Spider now. So this uses a language called Python, which we're going to be teaching you in the program. So this model I'm going to show you, we're actually going to get you to build a very similar model within the next few weeks. So here we go. Just load it up. So make that bigger so you can see it. So don't worry about understanding the details of this. And don't worry if you're looking at this thinking, oh my God, I don't understand a word of this. There's no way I'll be able to write something. I promise you, you will. You will be able to do this. And we are going to show you how you build such a model. And you will be very proud when you look back to today and think, I actually managed to build that. So I'm not going to go into details, but basically you'll be able to see here that we've emulated the process that I've described of going to the receptionist, then to the triage nurse, then to the treatment cubicle. Now, of course, the key word that I said when outlining this problem was, on average, patients arrive every 8 minutes, and on average, they take 2 minutes to be registered, etc. But of course, not all patients will arrive every 8 minutes. Not all patients will take exactly 2 minutes to be registered. There will be variability in the system. We'll talk more about that later. And that variability, turns out, is very important. So at the moment, I've got this set up for the base case scenario. So here, we can see I've got it set up so that we've got 1 receptionist, we've got 2 triage nurses, and we've got 4 treatment cubicles. So I'm just going to run that. Now, you may not be able to see this very well, so I'll read out what it says. So the average time in the system when I've run that is 128 minutes. Now, whenever we run a simulation like this, we don't just run a single iteration of the simulation. We run it lots and lots of times. So I'm just going to emulate that a minute. I'm just going to run it a couple more times, see what happens. So that one says about 158 minutes. Let's run that again. And that one says about 130 minutes. So we're looking about 2 to 3 hours-ish at the moment by the seams of it. What's quite interesting, though, if we also look at the average queuing time for each of these components, we can see the average queuing time for reception is less than half a minute. So there doesn't seem to be a queue forming there. The average queuing time for triage, again, about half a minute. But the average queuing time for treatment is about 90 to 120 minutes. Now, that might suggest to us that maybe if we were to remove a treatment cubicle, which is where the queue is, that might be more problematic. So again, it goes back to that sense of just running the base case, seeing what's happening now, seeing where the queues are forming, and seeing what might be a good idea and what might not be. But of course, the beauty of modeling, we can test this. So let's first of all get rid of the triage nurse. So we've got 2. Let's change that to 1. I'm going to run that model again. Let's see what happens. So this time it's come out 153 minutes. Well, that was within the range of sort of 2 to 3 hours that we saw before. 140 minutes. Just run it once more for luck. 143 minutes. So again, doesn't seem to have changed much. So that's good. That seems as though that might be a decision with minimal impact. Let's put that nurse back in. Let's now take out a treatment cubicle, and let's see what happens when we run that model again. Wow. Okay. So we've taken out 1 treatment cubicle, and our average time in system has now gone up to 51,565 minutes. It's quite a significant jump. Maybe we were just really unlucky. Let's run that again, see what happens. No, 51,000 minutes. So it seems like removing a treatment cubicle bad idea for this system. Now, in reality, all the time within health and social care, we're asked to make very quick, rapid-fire decisions about things that might have a significant impact on the service. And actually, the power of modelling is being able to try some of these things, build up a quick model of our system in virtual form, and test out these changes to see what impact they might have. And really, that's the core of operational research. It's all about providing us with evidence using these modeling, simulation, advanced analytical techniques in order to help inform decisions and improve the quality of decision making. That's basically OR in a nutshell. So what are some of the benefits of modeling? We've already seen some of this just from that really simple example. One of the key benefits of modeling is emulation. It allows us to take a version of reality that can be altered without risk or consequence. If we start playing around with things in the real world, then obviously, we can endanger patients. But if we try things in the model, we can do that risk-free. We've also got the advantage of speed. Typically, you can build a model, even a pretty complex model, much more quickly than you can affect changes in the real world. So getting a model together to test something out is usually a really good first step. There are also some sort of side benefits of modeling, which may not be at first obvious. So communication is a key one. A model, just the process of building a model, can help people to communicate and talk about a problem using a shared language, shared point of reference. And linked to that is this idea of systems thinking, just getting people starting to think about their systems, thinking about the processes within those systems. It's sometimes the modeling process itself, the building the model, is almost the least important part of the modeling process. Because actually, just by getting people to come together, talk about the system that they're in, talk about the processes, think in that systems kind of way, can really get some ideas flowing and really help people think about their system and how they might improve it. And the last sort of key benefit is one of objectivity. So a model can provide objective support for an argument, and it's particularly important where some of these decisions may well be politically charged or controversial in some way. Now, I do add the disclaimer: assuming the model has been built objectively, you can build a model to say anything you like. So you need to make sure that the model itself has been built objectively with the data that's available. But assuming it has, it can give that objective evidence that can help support decisions. So there are a huge range of modeling techniques within operational research, and this is by no means is an exhaustive list. And we're not going to take you through all of these things, in part because we don't do a lot of these things. So we don't really do a lot of scheduling or Markov modeling or that sort of thing. But what we are going to do in this course is to take you through virtually all of the things that we do. So we do discrete event simulation, we do agent-based simulation, system dynamics, forecasting, geographic modeling, all of those kinds of things we do. And so we're going to teach you the stuff that we do and focus on those things. But just to make you aware that there's a whole raft of stuff out there that's available. When you come to build a model and undertake a modeling project, it's very important that you're moving around something called the modeling cycle. And this is a very common thing in operational research. And this isn't a linear cycle either. It's a way, it's a very iterative process. And basically it says that you start with a problem situation, and then you, through analysis of that problem, conceptualizing that problem, structuring that problem, you then move to a conceptual model, which is kind of like a design for your model. How are you going to take that real world problem and create a design for a model that captures something about that real world that allows you to then answer a particular question? And we can check that back and validate it in some way against our problem situation to make sure that we're capturing the right things. Once we've got our conceptual model, we move to the formal model. So we turn that model design into the model itself. So that might be a computer simulation, might be a mathematical model. If you're doing live simulation, it might be a performance. But in some way, the actual model that you're going to be using, most of the time, it's going to be a computer model. And we check the logical validity of that model by checking to make sure that we've created a model that sufficiently accurately represents the design for the model that we made. Once we've got a formal model, we then use that to obtain solutions. And again, there's some validity that we assess to make sure that the right kind of solutions are coming out, that they match what we would expect. And then from those solutions, we then move to implement the change. And that may in itself raise further questions that we then can use modeling again to try and answer. So one of the key things to think about whenever you're designing a model is the objectives of the model. So you need to think about what you're trying to achieve by building this model. Why are you doing this? Why are you building a model? And a good way to think about it is in terms of these four things. So think about the problem statement. What's the problem? Can you define the problem in a simple statement? So let's imagine that your problem statement might be there's significant delays in referral to treatment. Now, it's all very well having a problem, but you also need to have some what-if questions. You need some potential solutions that you want to test to see which ones might be the best at trying to solve this problem. So an example what-if question might be, well, what if we reorganize the testing priority if our problem was delays in referral to treatment? And you'll usually have a number of what-if questions for any project. We also need to think about the deliverables. So what is it? What are going to be the outputs of this project? Are we going to deliver a report, present something to the board? Or are we developing a tool that we're going to show people how to use, and then they can use that on an ongoing use basis? There might be all sorts of things that we deliver at the project, but it's really important to be clear about that at the start. And also, crucially, to think about what the impact is going to be both for the organization and also for the service users, patients in most cases. So what's going to be the impact if you get this right? If you solve this problem, why should we care about that? Maybe it means that more lives are saved. Maybe it means that targets are met for the organization. These are all impacts that are really important to understand. And within the ARC, within Pencord, we're driven by impact. So all of the work we do is to generate impacts, generate positive, hopefully positive, real change for patients and for services. Another thing you need to think about when you're going through the modelling process is scope. And this can be a tricky one, particularly if you're sort of starting out in modelling. Scope is all about thinking what the boundaries of the system are that you need to model. So say you want to model your ED, you might be thinking, but a lot of them arrive by ambulance. So should I model ambulance dispatch too? Because that's part of that system. So it's really tempting whenever you're designing a model to immediately try and add more stuff in, to add more into the scope of the model. It's usually not a great idea to do that. And usually these two little questions are pretty good rules of thumb for designing models. First one, what's the minimum you can model to answer your question? You want to create the simplest model you can in order that you can sufficiently answer your question. And we'll come on to complexity and simplicity a little later. And the second question is, if I do need to model other systems or other aspects of the system, how can I simplify their representation within the model? And it's fundamentally because all any extra scope, any extra detail that you put into a model is just more ways of being wrong. So you want to generally try and create simple but effective models that answer your question sufficiently. Linked to that is the concept of how much detail you want to put into the model. So you might be thinking of a low-level detail model. So you might have a model that says, okay, the patient comes in, they're queuing. Is it a Monday? Yes, in which case Julie will book in the patient using the red folder. If not, well, is it an odd-numbered month? If it is, then John will book in the patient using the blue folder. But does it matter because Derek's going to collate the red and blue folders anyway? This sounds a very odd system, but you know that you get the gist of it there. Essentially, maybe it's important that those details are captured, but you need to reflect on if it is, because if it isn't, then maybe there's a better way to capture that course, going to the other extreme, you could have a very high level system that's just models. Patient arrives, they get triaged, they get seen by a doctor, and then they're either admitted or discharged. And it might be, in some cases, that's exactly the right level of modeling that you need to undertake. It all comes down again to those questions of what's the minimum you can model to answer your question? And if I need to model other systems, how can I simplify the representation? Have those questions at the forefront of your mind whenever you're thinking about how to model. And generally speaking, I would always advise err on the side of simplicity. You can always build in extra detail. It's much harder to rip stuff out. So always start simple, think simple. Our natural instinct is to try to capture everything, and that's usually a bad idea. We also, whenever we're doing any modeling, need to make a number of assumptions and simplifications. Now, assumptions are basically things that we need to assume about the real world because we don't know their real world properties. So it might be that we're assuming the data we've got is representative, for example. We're assuming that there are no travel times within the clinic for staff or patients, or that they're trivial, so we don't need to bother modeling them. And similarly, simplifications are things from the real world that we know more about, but we choose to distill them down in some way to simplify them because we don't feel the added complexity doesn't provides benefit. So it might be that we simplify the triage process into the patient spending an amount of time with a nurse, and that's good enough for our model. It might be that we simplify such that there are no limits to the queuing time for the MIU, for example. And then again, it might be that that's appropriate for our model. So this all really comes back to the point that all models are essentially wrong, and they're wrong because they are in themselves simplifications of reality. They do miss out and ignore bits of the real world, and in the natural and physical sciences, you get some very, very accurate predictors of what's happening, even though they're simplifications. My PhD was in biological science, for example. I created a very simple model of bee foraging behavior, but when we tested it against real bee behavior, it was incredibly accurate. So simple doesn't necessarily mean bad or unrealistic. Sorry, can we just make sure, I think somebody's unmuted. Can you just make sure you're muted? I'm getting quite a bit of feedback. In other areas, such as healthcare operations, a model may not be able to predict exactly what's going to happen, but that doesn't mean it's still not useful. And they're useful precisely because they are simplifications of reality. So here's an example. Here's an example of a model. This is a map of the underground tube map. Now that is a model, and that model is wrong. That model is wrong because that is not the geographic layout of the actual underground. But it's useful because if we were to model it as the actual geographic layout, it's very complicated. I would also argue, by the way, that I think that the tube map itself is quite complicated if you've never used it before, but it is much simpler than trying to understand that mess on the right, which is a more realistic representation of what the real world looks like. Similarly, here's another example. Let's imagine we've got a cardiac ICU with infinite capacity. Now that's clearly not realistic. That's clearly, that model is wrong, but it can be really useful. Having an infinite capacity model allows us to play around with things and say, well, let's imagine we've got infinite capacity. Where are the trade-offs? If we had 12 beds, here's the probability that we think we'll get bed blocking, for example. So those kind of models, they're not realistic, but they do give us really important and useful information for the real world. Models tend to come in two flavors of simplification. We get really simple models, tend to give you a feel for the direction of travel, and we get high fidelity models that try to tell you everything about where you're going, what time you'll get there, and everything else. And as a user and as a creator of models, it's your job to distinguish between the two and make sure that the results are not being misinterpreted. So it's fine to have a simple model. And you know, those are the kinds of models we normally build, as long as the people that are interpreting the results are aware that when your model says we're estimating a 2-hour wait for the ED, that they don't think that's a crystal ball prediction, that they understand that that's indicating some direction of travel, not exact predictor of, you know, how long it's going to take to queue for ED next Tuesday. Okay, just going to stop there. Any questions up to that point? Sean, have we had anything on the chat?
No, you're looking good, Dan.
Well, thank you very much. That's always nice to hear. Sorry, I'm just downing some water because my voice, my throat is getting progressively dry. I haven't talked for a while, so if you feel my voice getting faint, that'll be why. Okay, so we've talked about scope and level of detail and simplification in models. A key thing that we need to do whenever we're doing modeling is process mapping. Now, this is a really fundamental part of the modeling process because it's a way to try and capture the discrete processes within a system and the potential inputs and outputs to those processes in order to try and understand how our system works. And that's going to be really important when we translate from the real world to our conceptual model, to the design for our model. And it really is vital for understanding how your system works and is in itself really useful. We have had cases where we've gone in and done some process mapping, and just by getting people to talk about the system and understand how it works, sometimes that solves the problem, just by getting people to see, oh, I didn't realize we were doing that. Well, maybe we should just do this. So it can be really, really useful exercise in itself. And of course, it goes back to the question, how can you possibly start thinking about how you're going to improve your system if you don't even know what your system looks like? So what is a process? Let's think about this. Let's break this down. Processes are essentially activities that have a number of steps and which transform inputs into outputs. That's a very formal way of thinking about it, but can be helpful because we can also then think about our processes in terms of functions. A function essentially takes one or more inputs and outputs, has one or more outputs. It does something with those inputs and then chucks something out the other side. And it's really good to think about processes in that way, particularly for the way in which you are going to be modeling in terms of, as we gradually get you into things called object-oriented programming, which is where we do think in terms of those, feeding in inputs and doing something with them and then chucking out outputs. So that'll be a constant theme running through a lot of this. Now, process mapping is actually really easily, if you just bear in mind one simple rule, and I'm going to turn to my good old friend, Roy Walker. Say what you see. And it's as simple as that. Just describe what's happening in your system. That's what you're trying to capture. You want to capture, get on paper, get on in digital form in your process map on your computer, whatever it is, put up some post-it notes, get down what is happening in the real world, describe it, get it down in illustrated form. So here's some top process mapping tips, not from Roy Walker, this is from me. Have clear start and end points. Be very clear about how people are coming into your system and how they're leaving your system. And it may well be, in fact, in a lot of cases, there may well be multiple of each. You may have more than one way in which people come in and more than one way in which people can leave. And that's fine, as long as they're well defined. Make sure you're describing what really happens, not what should happen. The idea of a process map is to capture what's actually happening. So describe what is actually happening, even if you know that's wrong. Having said that, don't worry about those one-off exceptions to the process. People saying, oh yes, but I remember 3 years ago, this happened and that threw everything off. Well, if it's just a one-off, then you don't need to include it, unless that's particularly important for your question. Maybe those one-off events are fundamental to your question. Always, always process map as a team. If you just have one person that knows about the process, I can guarantee you there'll be things they don't know, even if they think they do. Everyone will have a different perception of the true system. Everyone will know something that the others don't, and everyone should contribute. And that can be really difficult because naturally there will be people who will be more confident talking in that. So if you're going to be running a process mapping session, which anybody going forward into phase 2, you will be needing to do this, make sure that everyone has a chance to contribute. That's really important for process mapping. Think about when you're doing that process map and you're asking the questions, think about the journey of the entities, which are usually patients, or if you're PSMA, it might be your suspects. But it might also be things like test results. That might be what you're modeling flowing through the system. But think about their journey through the system. How are they flowing between different processes in your system? That's what you're trying to map out. And use all of that to essentially create some kind of visual representation of your system. So here's an example process map. Don't worry about the details. It's one we did many years ago about for Torbay Hospital. But there's no right or wrong answer. And there's loads of different ways in which you may want to visualize your process map. There's no single right way. What is common is to use kind of flowchart notation as a way, as a framework for building up a process map, because it allows you to capture flows, processes, decisions, start and endpoints that are common with process maps. So you might want to format your process map like this, where you're mapping your entry points to the system. You're thinking about then flowing between various activities, processes, sub-processes, then flowing to different points, various decision points, and then flow over here if that decision's made, flow over here if that's true, etc. Exit points from the system. So that can be a really useful way, but don't feel inhibited by that. Don't feel as though if you have a process map, if you're doing a process map, you have to follow sort of exact process mapping nomenclature. As an example, so Kerry, who isn't with us today, she's just done a fantastic process map for a project that we're working on with the Royal Devon and Exeter Hospital, and has used her own style for doing that, and it's really good because it allows us, it's very clear, and it sets out what it's supposed to do. It sets out that it's an understanding of what's happening in this very complex system. That's the crucial thing. Another thing you'll need to think about when you're doing your process mapping and thinking about your project is who your stakeholders are. So these are people who have an interest and or influence on a problem and or its solution. And it can be quite tricky to think about stakeholders. Some will be obvious, but sometimes some won't be so obvious. So some of these questions may help you identify them. First of all, think about who owns the problem, who owns this problem, who will benefit from its solution, who might suffer from its solution. That's also really crucial to think about. There may be negative consequences from whatever decisions might be made, and so it's important to consider those people as well. Who's got a legitimate interest in the problem and or its solution, and who has the power to influence the process of solving the problem and implementing the solution. And those kind of questions are summed up in something I'm going to show you in a moment. Why is it important to consider who the stakeholders are for a project? Well, you're going to need to know, for a start, who holds the information you need and or the numerical data. No modelling project, and I'm waiting for Mike to quip, unless it's a system dynamics project, can survive without data. You need some data, whether that's numbers or information or something. You're going to need to ask people about things. So you're going to need to know who holds that information. You're also going to need to know who might help or hinder solving the problem or indeed implementing the solution. So we're able to build a model that proposes some fantastic solution. But then if somebody's going to block it for various political reasons or other reasons, you need to know about that. And maybe there's ways in which during the project you need to deal with that, maybe by bringing them on board and dealing with them. You also need to understand the nature of any potential conflicts, political conflicts or any other potential conflicts, how that might impact the work and how they might be mitigated. So one useful and easy way to think about stakeholders is to put them on something called an interest influence diagram. This is basically a 2D chart where we map interest on one axis and influence on the other. And we separate that map into 4 quadrants. So we've got people with low interest and low influence down in the bottom left. We've got people with high interest and high influence in the bottom right. And then in the other 2 corners, sorry, the top right, and then the other 2 corners, we've got people who are either very influential but not very interested, or very interested but not very influential. And the ways in which we will deal with each the people in those 4 quadrants will differ depending on where they sit. So if you've got somebody who's not very interested and not very influential, then just monitor them in case they move to one of these other things. So a good one that often sits in there is the general public. So it might be that the general public aren't particularly interested or are particularly influential, unless you do something that over here that's going to affect them or is controversial, in which case they could rapidly shoot across that chart. So it's very important to monitor those groups. You might have the people that are key players who are both interested and influential in this project. Those are probably the people on your project team or very close to your project team that you're engaging with closely. Then for the other two quadrants, you want to think about, so people who are very influential, but they're not really that interested in the project itself, just keep them satisfied. They just want to be satisfied that what you're doing is positive and it doesn't affect them negatively. And similarly, people who are really interested but actually don't have much influence, well, you want to keep them informed because they're interested and engaged, but they're not going to be able to help you much. So it's more a sort of keeping them informed. So thinking about those 4 different groups and how you'll deal with them, how you'll engage with them or not, can be really, really useful. Okay, I've talked for long enough and as expected gone over by 15 minutes. That's okay, I've built in a buffer this morning. You are now going to undertake your first exercise. Now, you have been provided with a fictional problem, which I will bring up in a moment. In your small groups, you're now going to, so in your peer support groups, you're going to spend the next 45 minutes reading through that problem. And then I want you to identify what you think the what if questions are. So what are the what if questions? What are the things that we'd want to ask a model in order to try and solve this problem? I want you then to build a process map of the base case system, so what's happening now, as it's being described in that document. And I also want you to build an interest influence diagram based on the stakeholders you think you'd need to consider if you're undertaking a project for this fictional problem. So all of you should have a file called exercise 1, should be a PDF file. Let's bring it up here. Oh, so you should have this. If you haven't, it is in the Slack channel for module 1. Have a read through that first, and then within your groups, we're then going to, I want you to do those 3 things. So what are the what if questions, build a process map, and build an interest influence diagram. Now, for all of these group exercises, obviously your primary means of communication will be chatting over Slack. You may want to arrange a call, so you may want to arrange your own sort of miniature Zoom call or Teams call. I know a number of you use Teams, and that's absolutely fine too. You can phone each other as far as I'm concerned. However this works for you to do this. But what I'm going to do after 45 minutes, we'll take a 5-minute comfort break. So we'll come back at 20 past 11. And I'm going to ask each group, somebody from each group, to share their screen and to present their process maps and their what if questions and their stakeholder diagrams. Sean, do we have any questions about any of that?
No, we just had a little one about saying, I assume the best people to have involved in process mapping are practitioners.
Yes, you absolutely want practitioners in there, but don't just have practitioners. So something I should have mentioned actually, as well as the quantity of people, making sure you've got a quantity, make sure you've got a good mix of people in there as well. So people that are on the front lines, people that are managing the process, people that hold the data about this process. You want to involve as many different types of people as you can. Everybody will have a slightly different perspective and or insight into this process. So process mapping is one of those things where you really want a good, strong group of that's large enough and mixed enough that you can get a really varied number of views. And it will be a bit of a nightmare initially, or seem a nightmare, because you've got so many views coming in at you and so many different ideas, etc. But that you'll get a rich mine of information from which you can try and build a process map. Anything else?
Nothing else on the chat at the moment.
Fantastic, thank you. Well, as I say, if anybody is stuck during any of this or has any questions, pop them in the HSMA Support Hub channel, and a mentor will be along to help you. But yeah, spend the next 45 minutes, take a 5-minute comfort break. So I'll tell you what, let's resume at 25 past. No, We'll stick to 20 past, otherwise we'll get too far behind. So make sure you take a 5-minute comfort break somewhere within that, and then we will come back at 20 past 11. You'll need to rejoin with the same Zoom details, and we'll see you then. And as I say, if you're stuck, chat on Slack. We'll be floating around, listening into the conversations. Really interested. Fantastic. Thank you. See you all soon.